So we will be discussing chapter 6 until 8. Okay. So each chapter I will just pick 2 questions. Okay. I did change a bit of the question to make sure that it is actually suitable for our course. Okay. Some of the questions are taking the examples from finance. Some of the examples are taking the example from something that we are not familiar with. So I think it's better to take the example that all of us are comfortable with. Okay, so chapter 6. Okay, so question 2, you can go to page 178. So I'm assuming that you also have gone through all these questions. So 178. Okay, question 2. Okay. So here, chapter 6 is about, what is it? Specification, right?
Yes.
Chapter 7?
Functional form.
Okay, functional form. Well, both chapter 6 and 7 are talking about specification, but if I'm not mistaken, chapter 6 is about relevant and irrelevant variables, while chapter 7 is on functional form, but both are specification. Okay, so here you have been hired by this automobile manufacturer, okay, to build a models of whatever. Okay, so basically this question is talking about, we want to see the factors that affecting um, the car prices. So normally we are looking at the house prices. Now we are looking at the car prices. So these are the variables that affecting the car prices. Okay. So what is it about? You build the following. Okay, you build the following models of the price of 35 different American-made US sedan. So 35 different, is it a car? Okay. So these are the variables, right? Okay, if you can look at the variables, we have how many? 4 with the standard error in parentheses, and your R bar square is 0.92. So this is uh, quite a good fit of data or model. Okay, so what is this P? P is your dependent. This is the list price of the ICE car, which is in thousands of dollars. So the moment that you can see the car, the price of the car is measured in terms of thousands of dollars. So you have to remember, when you want to interpret the changes, the variables, you have to multiply with thousands of dollars. And W is the weight of the car in hundreds of pounds. Okay, so what is your expectation regarding the weight? Is it plus or minus? Is it negative or positive?
Mm, positive.
So the higher the weight, the higher the price of the car.
Correct.
Yes.
Okay, so next is the dummy equals to 1 if the car has an automatic transmission. Okay, so when you have these features, what will you expect? Is it positive or negative impacts on the price?
Positive.
Positive. And then you have another dummy variables equals to 1 if the car has cruise control or 0 otherwise. So
Positive.
yes, when you have a cruise control, basically this is like a luxury car. Now, if you are talking about Kanchils or Myvi, they don't have this kind of features. Okay, L is the size of the engines of the ICE car in liter. Okay, the size of the engine. What would you expect for the size?
Positive also.
Positive.
Positive also, right? So you are assuming that when the engine is bigger, okay, so it has more power, who knows? Okay, and the price will be higher. So since you have learned multicollinearity, if you look at the variables, is there any variables that you think can explain one another? Any variables that uh
Is it the weight and size of engine, madam?
Yes. When I look at these variables, when your engine size is bigger, of course it will contribute to more weight of the car, right? So there is a correlation, a multi-core issues regarding the weight of the car and the size of the engine, because the bigger the size, uh, the more weight you have on the car. Okay, but again, when you talk about multi-core, of course, all the variables gonna have some correlation, but your concern is on the serious multi-core, severe multi-core. But looking at these two, it tells me that, well, you have to be careful about this because they are explaining one another. Okay, okay. So well, if you look at the equation, is there anything that you want to comment? The R bar square is good. How about the coefficient and the standard error?
Standard error for C is big, I don't.
Very big, right? So it increased about like more than 200 plus. Okay, so well, remember for the multi-core, when you have a multi-core, um, normally you're gonna have a high variance, okay, and then the R bar square normally very high as well, okay, and then you can also see these two variables are very similar to each other. Okay, just keep that in mind. Okay, now let's look at the question. Your firm's pricing expert, so you have the expert to actually determine the price of the car. Hypothesize positive sign for all the slope coefficient, okay, in the previous model. So test her expectation at the 5% level. So basically, when we talk about hypothesis testing, I assume that everyone knows how to do it. Of course, you have 6 steps, okay? So I don't plan to explain the hypothesis because this is just very straightforward, because they ask you to test all the variables. You have 4 variables. So of course the first step is that you're gonna have your H null. I will just make it general. Your H null and HA. So what is your HA? So normally we're gonna start with the HA or H alternative. So what is it? So if you can see here, the expert hypothesized positive sign for all the coefficient. So basically, you test from beta 1, and then you have another hypothesis for beta 2 until beta. How many beta do you have? 1, 2, 3, 4. Until 4 variables, and then all the sign is because it is positive. So it's bigger than 0. So the same thing with the H null, you have to put the opposite sign and equal sign equals to 0. So basically, you have to do individual hypothesis, individual 6 steps. Okay. And then step 2, you are going to use your alpha equals to 0.05. And then step 3, what will you do in step 3? You have to find your test statistic. In this case, you will be using t statistics. Okay, so I'm assuming that you know how to find the t, even though the equation doesn't give you the coefficient, doesn't give you the test statistics. So I'm assuming that you should know. You can take the value of your beta, expected beta divided with
Error of
standard error of the beta. So
ahead.
so you will get a individual t statistic for each of the variables. Okay, so you can just do for all these 4 variables. Okay, I will not do it because it will be a long working. Okay, number 4, you have to find the CV. How to find the CV? You have to refer to T table, right? And
Yes.
then
Yes.
Go
what
to
is your
one
degree
third.
of freedom? Okay, yeah, one tail. Okay, let's go to one tail, and then
And then degree of
what?
freedom n minus k minus 1.
N minus k minus 1. So what is your n? You are talking about how many different?
35.
35.
35. Okay, so you have 35 minus k, which is 4 minus 1. 1 is actually refers to your beta knot. So normally what I did is that I will just minus everything. 1, 2, 3, 4, 5, including the beta knot. So yeah, the same thing. Okay. And then once you got the CV, you should know the rejection region. And then you can just draw your diagram to show which rejection region are you talking about. And then plot T statistic, whether it is inside rejection region or outside. And then number 5, you make a decision whether you wanna reject or do not reject your hash null. Don't reject hash 1. Okay, and then number 6, you have to interpret what does it mean. Okay, because sometimes when you interpret, you will just say, okay, beta 1 bigger than 0. This is not interpretation. You should tell what does it mean. It means that what is beta 1? Weight has a positive impacts on the change in the price of the car. So you have to interpret. Okay, so you have 6 steps. Each of the step worth 1 mark. Okay, so I will leave that to you. This is number A. Number B. If you have any question, you just let me know. B. What econometric problems? Okay, when we talk about econometric problem, you can talk about specification issues. You can talk about multi-core, serial correlation, and heteroscedasticity. These are what you call econometric problem. And specification, you have 3 things, right? Uh, Irrelevant variables, incorrect functional form, and you can just ignore the error term under the specification. Okay, so what kind of econometric problem appear to exist in the previous model?
Multi-call.
Yes, right. Because, well, the size of the engine is very similar to the weight of the car. You just wanna show when the car is big, when the car weight a lot, so it has some impacts on the price. So they are like the same variable. So you can just drop one. Okay, but remember, if you wanna drop one, you have to drop. You have to refer to the theory. Okay. Well, you have Maltico. What else? Because it's purposely specifically mentioned in particular, does the size of coefficient of C cause any concern? C is actually, if you look at here, the previous model, okay, you can see that the variable C, even though it is just a dummy variable, but it has a high standard error. So does it give a concern? Of course. But why is that? So normally, when you have a multi-core issue, you will also cause a high variance or high standard error. But when you also have issues with omitted relevant variable, so you also gonna cause bias to this standard error, means that you will increase the standard error. Okay, so in a normal question, when they ask you what is the possible econometric problem, the first thing that you have to think, not a multi-core, you have to think whether you have included the relevant variable. Means that when you check the all the variable given, make sure that uh, it covers all the relevant one. Okay, so you have to think what are the other potential or relevant variable that should be included in this equation. That is the first thing. Think about, when they talk about econometric problem, think about um, omitted relevant variable. Okay, so you have to figure out what are the other possible relevant variable that should be included in the equation. And second, you should think, you have to look at the variable. Are they all relevant? So look at the existing variable in the model, in your model. Okay, so now we have gone through number 2, which is that when we look at the all the variable, we said that, well, the weight and the size shouldn't be together. You should drop one. Okay, so we have addressed number 2. How about omitted relevant variable? Do you think that factors that affecting the price of the car only by the weight, by the dummy where the car is automatic, or the car has cruise, and the size? Is that all? Is there any other variable that you think can affect uh, the price of your car? Any other variable that you think relevant?
The
Anyone?
is it
Uh,
the brand of the car, madam?
Yes, of course. If you want to purchase Myvi and you want to purchase BMW, do you think that they will have the same price? Of course, different, right? So the brand of the car, what else? Anything else that you think can affect the we are talking about the new car. If you are talking about the used car, of course the mileage whatsoever, right? But we are talking about the new car. What do you think that can affect the price of the car? Of course the features of the car, right?
Yes.
Yeah, some maybe what else other than the features of the car? Some car has a very basic feature. Some car has so many makeup inside it, right? So many things. So it of course the price will be higher. What else other than that? What can you think of?
Fuel consumption, madam.
Fuel consumption?
Yes.
How? How?
How this car like have eco features like my like current Beza and some like other car doesn't have it.
So the one that has an eco features is more expensive.
I guess yes.
Okay, okay. That could make sense. Other than that? Other than that? Anything else? Well, for the brothers, you should know better, right? Okay, so basically, when you look at like question B, when they ask about econometric problem, you have to find out what are the other possible omitted relevant variable. You can just pick one example that should be sufficient enough. Okay, and then what could be the problem? So the problem could be many omitted relevant variable, and then you include irrelevant, what we can say, they are not irrelevant, it's just that it is not irrelevant. Basically it is multi-core, the variables are relevant but they are just measuring the same thing. Okay, so you have two issues, multi-core and omitted relevant variable, and you decide to test the possibility that L, what is this L, the size of the engine, is an irrelevant variable by dropping it and rerunning the equation. So now you rerun the equation. Okay, so if you can see here, they put a hint. Be sure to use our 4 specification criteria. Remember, when you want to add or drop the variables, you have to refer to our guideline. So we have 4 guideline for specification. What are the guideline? So basically, this guideline you have to remember by heart, because whenever the question asks about whether we should add this variable or drop this variable, you have to refer to this. Okay. Okay. We are talking about the size of engine, right? Okay. So, let's look at the guideline. The first guideline is that, okay, the theory is the variable supported by the theory. Okay. So let me, where should I put, is it here so that you can see the guideline? We are talking about the size of the engine. So basically, according to the theory, when the engine size is big, of course, the price will be high. Okay, so well, theory said it is actually relevant. Okay, so what you're gonna do when you are referring to this criteria, I think it's better for me to write down. So the first criteria is okay, theory. Second, t-test. So t-test should be following the expected sign and should be significant. Okay. Okay, number 3, R bar square, whether R bar square increase or decrease. Number 4, bias, whether it introduce a bias when you drop or add the variable. Okay, now. Okay, theory said that, well, the size of the engine uh, is in fact a relevant variable to affect the change in price. Okay, theory said that it should maintain. I mean, the size of the engine should be in the equation. How about t-test? For the L, what is the t-test? Is the t-test significant? L. So, where is your L just now? Here. Okay, so basically, if you look at here, you are having small number. When you divide with this, you will also get a small number. So here, the t-test is actually not significant. Okay, so it's not significant. Does it follow the expected sign? It's follow, but it is not significant. So according to the t-test, it says that you should actually drop this variable. So drop, I put cross. Okay, how about r bar square? So when you drop the previous r bar square is 0.92. When you drop the L, what happened? Your r bar square is improved or reduced?
Improve little bit only.
Okay, at least it improved, right? So r bar improved means that the previous L shouldn't be in the equation because improve means it does improve the estimation, even though a little bit. So how about the bias? When you drop this L, okay, does it introduce bias to the other coefficient? That is the meaning of bias. Okay, so before that, you have to look at the previous coefficient. So for the W, 0.28. For the T, 1.2. For the C, 5. Okay, I think it's better for me to write down, or else I don't remember. Okay, so for the, you have W, the coefficient is 0.28. For the T, it is 1.2. For the C, 5.8. So you want to see this coefficient shouldn't have a bias. Bias means that they will not change a lot. So look at here. The W from 0.28 in 0.29, not so much. T doesn't change at all. C change a bit. So it doesn't really introduce a bias. So if it is doesn't really introduce a bias according to this what we call criteria, we should actually drop the L. So now you have 4 criteria. So based on these four criteria, what does it say? It says that only one suggests that you have to maintain the L because it is supported by the theory. Okay, the rest of the criteria said that you have to drop it. So this is 3/4. The majority said that drop it. And if you look at the theory, although the theory has supported this variable, but because when you look at the other problem, L and W, it has a multi-co. So when, even though the specification support it, not so much, only this theory, but because it create multi-co, so you have to drop one of them. Okay, so that is the answer for B. The answer for C. Okay, so basically you have to remember these 4 specification criteria. Number 3, this is number 3. This is a different question. Okay, so far so good?
Yes, madam.
Okay, you know, I'm so sleepy. Okay, so next, this is question 4. Okay, I think I changed this question. Did I? Or was it the original question? Question 4. Okay. So for each of the following situation, determine the sign and, if possible, comment on the likely size of the expected bias introduced by omitting a variable. Remember, when you have omitted your relevant variable, this omitted variable will actually introduce bias to the existing equation. So you want to see what kind of bias does the omitting variable create to the existing one. Okay, number 1. In an equation for the demand for peanut butter, the impacts of the coefficients of disposable income of omitting the price of peanut butter. Okay, so let me put, this is A. What is your, this is demand for peanut butter. Well, demand and consumptions for peanut butter are the same, right? So let me put, this is demand for peanut butter. So it's a functions of, you can have like beta naught plus beta 1. This is like what we call the general equation. Beta 1 is disposable income, YD. Okay, so basically you should also have the price of the peanut butter, but somehow the price of peanut butter was omitted. Then you only have error term. Okay, so what is omitted here? You have omitted somehow the price of peanut butter. So you know that this price is actually relevant variable in what? In affecting your demand for peanut butter, right? Well, I think if we put demand, I don't know. I think it's better to put consumption for peanut butter, but they are the same thing. Which one do you prefer? The demand for peanut butter or consumption for peanut butter?
Consumption.
Consumption, right?
Mm.
Okay, so yeah, it's consumption. So yeah, demand and consumption are the same. Okay, so you know that the price of the peanut butter will affect your consumption for peanut butter, but you somehow you omit the peanut butter. Okay, so now let's look at the individual relationship. What is the sign for income on the consumptions of peanut butter? What is the expected sign?
Positive.
Okay, positive, right? Relationship mean expected sign. So when your income is high, of course, you will consume more, right? Okay, how about the price of the peanut butter? Is it positive?
Negative. Higher price. Lower
Negative.
consumption.
Yes, so higher price, lower consumption. So now your income is positive, but then because you omitted the price, so the price is negative. What happened is that this negative will affect this the plus sign of the income. So what happened is that you have plus minus. When you have plus minus, what will you get? What is the bias? It will become minus. Okay, so this is the bias that you introduce when you omit the price, because price has a negative relationship with the demand, but you omit it, so this negative will affect the disposable income. Okay, so basically your bias is negative. Okay, so how about B? In an earning equations of worker, so you are talking about earning, the impacts of coefficients of experience of omitting the variables for age. So you are talking about earning. So maybe I will put Y referring to incomes or earning. Okay, so what is the variable? So I will just keep beta note and error term. I will just put the variables. Coefficients of experience. Experience. Okay, what is your omitted one? The omitted one is actually age. Okay, so tell me, what is the signs of experience on the earning?
Positive.
Of course, when you have more experience, we assume that you will have more earning, more income. How about the age?
Positive.
What is it? Positive?
Positive.
Okay, so we assume that because they didn't put age square, okay, they just put age. So we assume that the higher your age means that the more senior you are, the higher your earning, right? Okay, so age is positive. I will not put age and experience together. They will become multico, but it's okay because this textbook just give you the example, right? But basically, you shouldn't put experience and age together. Okay, it's fine. So age is positive. Higher your age, more experience more senior you are, so more income you will get. So now, experience is already positive. Then you omit the age. Okay, so what happened is that age will introduce bias to experience. What is the bias? So you have positive and positive. The bias will be positive. Okay, so far so good.
Yes.
See, easy, right? So that's why you can just do it by yourself. You don't need the tutorial. In a production function, okay, so this is like production. So in economics, when we talk about production, we normally put production is like output. So output, let me put just output. Normally we put Y as the output, but it's okay, just put output. What is the function? The impacts of coefficients of labor. So labor,
The
uh,
capital.
mm,
Omitting the capital.
capital. Okay, so tell me, what is the sign of labor on output? More labor you hire, what happened to your output?
More higher production.
More production, more output, right? So positive. How about capital? The more you invest your money into the capital, what happened to your output, your production?
Increase.
Increase.
What is it?
Increase. Positive.
Positive.
Also positive. Right. So what happened? So now
Positive bias.
you have positive, so you have positive bias. Okay, you want to see D or should we just skip? Move to the next one. Should we proceed?
Yes.
I don't know what is yes means. Is it proceed? Is it skip? In an
Proceed.
equation for okay, in an equation for daily attendance. So this is the attendance at outdoor concert. So like your attendance, whether you want to attend the concert or not, the impacts of coefficients of the weekend dummy. So 1 equals to weekend or 0 otherwise. So this is weekend. Okay, what is the omitted variables? Probability of precipitations at the concert time. Okay, so let me put the, this is the precipitation. Precipitation is like the probability of raining. Okay. Okay, so do you think that if you know that the probability of raining will be high, will you go to the concert?
No.
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 Okay, so what is the sign for uh, precipitation?
Negative.
Yes.
Negative, right? Okay, higher the probability of raining, lower your attendance to the concert. Okay, how about the weekend? Do you think that if you want to go to the concert, it will depends on the weekend? The concert will happen anytime, weekends or weekday. Does it affect you? I mean, you will only go on weekend or it doesn't matter? If let's say you love Siti Nurhaliza so much, regardless whether it is weekends or not weekend, you will just go, right?
Yes.
So do you think that weekend ha- is a good variable? Has a positive or negative sign on the attendance?
No.
Uh, mm,
Is
maybe
weekend a relevant variable?
medium.
No.
Medium.
Uh-huh.
But
Hmm?
if we can, many more people will attend, right? Because it's not a working day. Can.
Yeah, many people will attend, but then you have to know that it's not really something like common that the concert will be conducted on weekend. It can be conducted anytime, right? It's not necessary that weekend will be affecting the attendance. Don't you think so? Regardless whether it will be conducted on weekend or weekdays, people will come. Don't you think so?
Oh, okay.
Don't you think so? Yeah, right. So weekend doesn't really have an impact on attendance. So that's why we put like zero correlation, zero relationship. So zero with negative. So basically zero. Okay, is it clear?
Yeah.
Okay. So let's move to the next one. So you have to look at each variable. Do they actually represent relevant variables or not? If they are not relevant, zero. If they are relevant, then look at the omitted one. What is the sign of the omitted one? If it is negative, then look at the sign of your existing variable. Is it positive as well, or is it negative? If let's say you have both negative, it's become positive bias and so on. Okay. Mm. Mm. That is question 4. Okay, then we move to chapter 7, question 2. Chapter 7, question 2, 210. 210, question 2. Okay, well, chapter 7 is about functional form. So the question is meant to cater for functional form. Okay, so you will be seeing this in your final exam as well. That's why when we discuss about functional form, I went very slow, right? So these are like the example. How will the functional form question will be asked? Okay, for each of the following pairs of dependent and independent, pick the functional form that you think is likely to be appropriate, and then explain your reasoning. Okay, so now okay, so I think by looking at this variable, you should know how they look like, right? I don't really have to write y equals to uh x. No, what y is actually sales. So I don't really have to write down sales equals to disposable income, or I need to write down. Should I write it down or there is no need?
Write down, madam, write down.
Okay. So what do you think about this functional form? Is it lin, linear, lin log, lin, log? What else? You have a polynomial. What is it?
Don't know, madam.
Eh? So remember, okay, income is like your earning, right? They are the same thing, something that you earn. Okay. So remember when we talk about earning, I did mention in class the number is huge, a large number. Okay. Normally when we are dealing with a large number, we like to make it small. How to make it small? We put a log so that it will become a small in number. And normally when you want to interpret the earning or the income, you will interpret them. It's like when the income increased by this percent or reduced by whatever percent, you will interpret them in terms of percentage. Okay, you will not say when the person income increased by 1 ringgit or 1.2 ringgit. So you will not say that. You will just explain in terms of percentage. So the moment that you see the word income or earning, they should be in log. Okay, so remember when we talk about log, when we learn this topic, means that when the income increased by a large number, log, right? Or decreased by a large thing, a large number. When your income increased by a large number, do you think that the sales of the shoes will also increase by a large number?
Yeah.
For example, your income increased by 100%. Do you think that people will just simply buy shoes and shoes will also increase by 100%?
Can
No.
buy more shoes, madam?
Not
You
really.
can buy, yeah, you can buy more shoes. Of course, we are saying that when income increase, sales of the shoes will increase. But now my question is, does it mean that when your income increase by 100%, you will also buy 100 shoes? No,
No.
right? So
The increase is not the
you
same.
will buy the shoes, but not so much like the increment in your income. Because when your income increase, you will not just buy the shoes, you will buy many other things. You may want to go to this concert just now, right? You may want to treat your girlfriends and so on, isn't it? So the sales of the shoes will not also increase a lot. Means that even though your income increase a lot, the sale increase by uh, a bit. So this is what you call a lean log. Means that the increment in income is a lot, but the increment in sales is not so much. Okay? So far so good?
Yes.
Okay. You really need to see me writing down the equation, even though you can picture by yourself, right? So B, this is the attendance. Attendance at the Hollywood blah 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 concert. This is attendance for your concert. And X is what? Whether the orchestra's most famous conductor was scheduled to conduct that night. Okay, this is like whether the famous one conducted that night or the non-famous one. This is like a dummy. One is the famous, zero otherwise. Okay, so this is like the famous or non-famous. So when this is a dummy variable, when you have a dummy variable, normally when you want to explain it, if one is like by one unit. Okay, so just remember when you are talking about the dummy variable, there are linear. Okay, it's a lin equation. Okay, because it's a dummy. You don't explain dummy in terms of if if it's like if one male, zero female. If male increase by 100%, no, you don't explain that way. Okay, so it's just linear. So C, aggregate. Okay, so there are many forms when you talk about aggregate. So you have aggregate consumption. Aggregate consumption is the functions of aggregate disposable income in the US. So you're talking about the whole country. Okay. So what do you think it will be?
Lean log.
Lean log. Why? Because the answer said so. Is it? You
Is
have
it
to make
because
sure that
the increases in consumption will not be as much as the increase in income. Therefore, if income
okay,
increased by a lot, consumption will only increase by a little bit.
a
So
bit.
that's why we use
Okay.
lean log.
Lean log. Okay. Okay, that's good. Because it is very similar to the previous one, right? Okay, so you can have lean log. Okay, this is one form. You can also have double log. Because when you talk about aggregate, we are talking about a large number. So normally a large number, you will use log so that it will smooth the estimation. Okay, you can use lean log. You can also use log, depending on your justification. Okay. Okay. So far so good. Can I proceed? This is number. Sorry.
You can proceed, madam.
Okay, so D, the money supply. Wow, when you talk about money supply, this is log. Okay, this is money supply equals to interest rate. Okay. So, well, this is actually a macro variables. So you should know what is macro variable, what is micro variable. When you talk about micro variable, we are looking at the household, the micro level units. When you are talking about macro is a big data. You are looking at the whole country. So when you talk about macro data, basically the form is actually log. It's a large data. The same thing with aggregate consumption and aggregate income. When you talk about the aggregate macro data, normally we are using log. Okay, but here for the C, you can also use lean log. But normally when we wanna estimate the equation, we will just use double log. Okay. That is D, and then the last one is E. What is it? Average production cost. This is production cost is a function of what? Number of box of pasta produced. Number of box of pasta of whatever, right? Pasta produced. What is it? When you talk about the cost, we have discussed this in class. When you talk about the cost, what happened? Of course, when you produce a product, okay, the cost will the more you produce, the cost will increase. But after certain point, you have achieved the economies of scale. What happened to the cost?
Decrease.
It will keep decreasing, right? So I think you have learned this, right? This is zero. This is your production. This is the output. I don't know which one is this is the cost. Okay, so when you keep producing, of course you from zero you have no cost, but the more you produce, the cost will keep increasing. But after certain point you have achieved the economies of scale, the cost will keep reducing. Okay, so what is this functional form? You are calling it quadratic
Polynomial
or
quadratic.
polynomial. Both are okay. Quadratic is also fine. Polynomial is also fine. Okay. So yeah, I think you love what is this functional form very much, right? So their functional form depends on their relationship. How does they affect the y? Okay. So that is number 2. Question 6. Page 215. Where's 215. 6. Okay, another functional form. Okay, wow. Suggest the appropriate functional form for the relationship between the following variables. And you have to explain your reason. Okay, so you want me to write down, right? The equation, the age of the ice house in a cross-sectional equation for the sales price of houses in the Cooperstown. So you are talking about the sales. You wanna look at the relationship, the impacts of age for the sales of the for the sale price of the house. So this is the sale sales price, and then this is the age of the house. What do you think the impacts of age on the price? Well, basically, instead of putting sales, just looking at the price of the house. So before answering this question, you have to look at the hint. Cooperstown is known as a lovely town with a number of elegant historic homes. So basically, this home are actually historic one, like a museum. Okay, so they have some values. Okay, so what is the impacts of age on the price? What do you think?
Positive.
Positive? Is it positive? Only positive? We did mention about age before, right? Can you explain what do you mean by positive? Increase the age of the house means that the price will be higher.
Because the more historic the building is, it will have more value.
Okay. Anyone else? Anyone else? Who wanna try to explain this relationship? Ayo, no one is brave enough to explain, right? This is the price of the house. This is the age. Okay. So normally, we assume, well, this is not we assume. The theory said that if the house is getting older, the higher the age of the house, of course, the price will fall. Okay, you have a house built in 2010, and then you have a house built in 2020. Will you purchase the house in 2010 or 2020? The house in 2010, they are using a very all updated design. They are using whatever materials, but the house built in 2020, they have a contemporary design and so many new features. So will you purchase house built in 2010 or 2020 as a smart consumer if their price are the same? Which one will
2020.
The latest.
the latest version, right? So it says that, okay, when we talk about the age of the house, okay, this is the age. So if the age is more, the price will be lower. The older the house, the lower the price will be. Okay, so normally you will have a downward sloping. This is a normal relationship of age on the price. But because now it says that this we are talking about historic home, means that after sometimes means that this house historic home means that it is a very old house. So the older the house get means that the plastic it gets, so the value will keep increasing. So they have to be very old. Okay, so normally by default when the age is high, the price will fall. But if they get too old, then the price start to increase because now people start to value their what we call their not really sentimental value, start to value their uh elegant historic value. Okay, so basically the functional form is
Not
Quadratic.
new.
log in. This is
Quadratic.
quadratic. This is quadratic. Okay, so when you have something like this, it is quadratic. Okay, B. The price of a natural gas in year T. When you talk about cross, this is year T. When you talk about time series, normally we're gonna use log. Okay, it's a time series. Okay, the price of natural gas in year T in the demand side. Demand side is a log. Time series equation for the consumptions of. Okay, so you have a consumption of natural gas, whatever consumption, and the price. But because we are talking about time series, for time series, we're gonna use log. Okay, a double log. Okay, LOG. Okay. So C. The incomes of the i's individual in a cross-sectional equation for the number of stood on by individual. So this is, and then this is the income. What is the relationship? Higher your income, what is the relationship? This is just like a normal cloth, right? So higher your income,
The more suit will be
will you purchase, right? So what is the relationship?
positive.
Positive. Now, well, you have the income, isn't it? You should know the functional form. What is it? It should be lean log. Yes, LOG. Okay. So yeah, because if remember, even though your income increased by 100%, you will not purchase the whatever item by 100% as well. You will purchase a bit, okay? Because you have so many other spending. You will not just spend on a particular item because your income increased by 100%. Okay. So next, the the dummy variables. This is a dummy variable. So don't worry about dummy. Normally for the dummy, what happened? You will have?
Lean.
Yes. So it should be clear. Don't worry about the dummy. It's just linear. Okay. So done with number 6. This is chapter 7, question 6. Wow, you are very fast. Am I going too fast? No, right? Is it yes?
No, I think
No,
that's
madam.
Okay, so let's move to, we have done chapter 7. Let's move to chapter 8. I know that you don't want to see chapter 8 in your midterm, but because we have covered chapter 8, so I'll just look at the question. We'll just discuss the question. So chapter 8, page number 241. 241. Question number? 2. Okay. 241.
then
Okay. Okay. Now, so well, because this chapter is about multi-core, so you should, of course, expected that you will be seeing multi-core problem. But just assume that later on in the final exam, you will never know whether the equation is suffering from multi-core or not. At the moment, you are just seeing multi-core, but you will also see serial correlation. You will also have a issue of heteroscedasticity. So just keep in mind that you may face many econometric problem. Okay, so a recent study of salaries, this is like your income of elementary school teacher in a small school district in this area came up with the following estimated equation. Okay, so you can see the notes. T score in parentheses. So by default, in parentheses should be your standard error. Okay, but this is just, they just don't want to show the standard error. So please pay attention to this, okay? Because this is not something common. You will put standard error in parentheses. Okay, so this is salary. You can see that they put loan. So when we talk about salary, income, earning, you should know it should be in log. But they are the same thing. Okay, so you have 1, 2, 3, 4 variables. I cannot tell what are they, but I know that you can tell what are they, right? Okay, so now before looking at what these variables are, can you tell me what is your observation based on this data? What is it that you can observe? Everything is fine?
High standard error, madam.
High standard error? Remember, the number in parentheses is not your standard error.
score.
The number in parentheses, I keep mentioning, it is T-score.
Oh, T-score. High T-score.
So low means the smaller the than ever.
Smaller error.
How will you know smaller error?
Because
Now you,
it explains the variable really well. Like, I don't
now you get confused because you couldn't see your standard error. There is a reason why they simply change t-score, standard error to t-score to make you confused, and you get confused. Okay, so basically, remember the formula of computing your t-score is actually your coefficient, your betas, whatever betas over standard error, right? But now they didn't give you the standard error. Instead, they give you the t. Okay, they give you the t. Okay, so if let's say your coefficient is large, okay, how will I put large? Large, and the standard error is small. So basically, you will have a large value of t. Means that your t will be significant. Okay, but now you can see 2.3. Well, this is good. 2 point something, but the first one, amp, the first EMP, your T score is small. When your T score is small, basically your standard error is large. That's why you're gonna have the small T score. Okay, and when your T score is small, basically it is not significant. Something wrong with this EMP. So you have to, uh, pay attention to this. Okay. Okay, and then how about your R bar square? R bar square, this is what? Is this cross-sectional or time series? For cross-sectional, 86% is quite large. You have a high R bar square. You also have insignificance of T. What else? That's it. Okay. So now let's look at the measurement. So cell is your salary in dollar. Okay, this is just 1 unit. EMP is the year of the I teacher has worked in this school district. So you want to find out what are the factors affecting the increment in salary. Okay, and then okay. So before I move to unit, what is the expected sign for years that the teacher has worked in this school? What is the expected sign? When the teacher has worked for quite some time, for a longer year, what happened to their salary?
Increase.
Increase. Oh, I think you want to see the equation, right? You love to see my bad handwriting. So I will put income or salary is a functions of beta naught plus beta 1. This is, they put EMP, but it is years. But it's okay. EMP plus beta 2. What do we have? Unit. I don't know what is this unit, plus beta 3. This is LANG. And then plus beta 4. This is maybe experience. Yeah. Okay. So you are expecting that the EMP, which is the year, will have a positive impact. The longer he has been working in that school, the higher the income. How about unit? The units of graduate work completed by the I teacher. What do you think about this sign? Graduate work completed by the teacher. Do you think that it will have an impact on their salary? Anyone? Anyone?
Madam, what is graduate work?
I cannot explain. Graduate work normally, this is the work done by the. It's like research work, research based work, but it is not relevant. It doesn't really affect the salary of the teacher.
Oh,
If this is not a school teacher, university lecturer, we are expecting to do some research based. Okay, graduate work means that research based stuff. But for the school teacher, um, they never required to actually do something on the research. So, well, they just put it there to to confuse you, to ask you whether you think that this is a relevant or irrelevant variables. Okay, so what do you think about this? The unit, the graduate work. What will be designed? if they write more papers, do more work, do you think that it has an
Positive.
impact? It has an impact on their salary?
Unsure,
If
maybe.
they do more research, do you think that it has an impact on their salary?
Yes. Maybe.
Mm, okay, as I mentioned to you, for the school teacher, they are not required to write papers. They are not required to publish an article. But for the university students, we are required because that is the requirement for us to get the promoted, to being promoted. But it is not the requirement for the school teacher. So do you think that this is a relevant variable in the first place?
Irrelevant.
No.
No.
So if it is
No.
not relevant variable, it shouldn't have any impact. So basically, this is actually zero. No impact at all for the school teacher. I'm not sure if, let's say, the school teacher in the US required to do research work, but here, let's assume that we are using Malaysian, even though it is in dollar, but in Malaysia, it is not really a requirement. Okay? So how about lang? The dummy variable equals to 1 if the teacher speak two languages. What do you think? If the teacher speak two languages, does it has an impact on their salary compared to those who are who use one language?
Yes.
No.
We are talking about school teacher. In Malaysia, all teachers are communicating or teaching using bahasa. If even though they learn English, does it has an impact for them in their salary? They are
No.
teaching using bahasa.
No.
No.
It has no impact, right?
Yes.
Okay. Well, what is the relationship then?
Zero.
Zero.
It is zero if it is like a national school. But if let's say you are talking about Mandarin school, maybe they are required to have these two languages. Okay. Okay. So experience. What do you think about experience?
Positive.
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 Positive. Okay. So okay. Now looking at these variables, what can you tell? Looking at these four variables, what can you tell? Before we go to this question, what can you tell? Is there anything? Are they all relevant variable?
Not all relevant, and
No.
two variable has multiple because the years
Yes.
and the experience.
I was waiting for that. There are so many issues with this equation. There are so many factors that can affect the salary, right? There are so many factors. Yet they are taking two irrelevant variables. Okay, so they because they want you to find out what are the econometric problem. So they give you two irrelevant variables, and then the other two are also having the multi-co, right? So you can see why years of school, years that the teacher has worked in school, and the experience having multi-co. Because if you are working for so long, of course you will have more experience. So basically, these variables are talking about the same thing. Okay, and if you want to drop these two variables, we will drop the years because the experience is of course one of the factors that affect the salary. So you will drop the years. Okay. Okay. So let's look at the question. Make up and test hypothesis for the coefficient. Okay. So all these variables. Okay, I will just skip that. What is the functional form of this equation? What is the functional form? You are talking about income, right?
Log lin. Maybe.
Yes. And these are some of them are what we call dummy. Dummy cannot take any other form. It's just ln. So it's just lin. So this is log lin. Okay. So functional form is very straightforward. Does it seem appropriate? Of course. You can explain, right? When you talk about income, because you explain it in terms of percentage, and income normally will increase a lot, okay, but the other thing will not increase as much, okay. What econometric problem? I think we have discussed, right? Out of irrelevant variable, you have two omitted variable. Of course, you will have omitted. There are so many factors that affect your salary. What are the other factors? Can you give one or two? What do you think can affect your salary other than experience? At the moment, you only have one factors that affect your salary, experience. What else?
Madam, if we say the maybe education level, because teachers that have master or PhD maybe have difference in their own salary.
Okay, education can also affect their income, of course. Okay, if let's say they have a lower education, maybe they will be teaching the lower grades. If they are having a higher education level, they will be assigned to teach a higher grades. That is possible as well. What else? So you have education level. What else that you think can affect the salary? Only two factors? Don't you have internet, I mean Google, and search what are the factors?
Gender, madam.
Yes, I'm about to search what is the factors affecting salary. Okay, gender, of course. What else? Anything else? What else? Affecting salary.
Specialization.
Explain.
Type of school, madam. In international or private school, they may earn more salary compared to public school.
Yep, that is also possible. Types of school, and then explain what do you mean by types of school, international and national. International, maybe they are using international standards, okay. So you can actually give a few variables, okay. Basically, just giving one relevant variable should be sufficient, just to tell us that you have omitted relevant variable, and then just give examples of relevant variable that has been omitted, okay. And what else? So what econometric problem? You have irrelevant, two irrelevant, you have omitted, you can list whatever, and multi-co as well. Does this equation appear? Yes. Explain. Okay, so you can explain. Suppose that you now are told that the simple correlation coefficient between years and experience is 0.89, and the VIF are both just barely over 5. Does this change your answer to part C? Your part C, you are saying that they are having multi-co. So by looking at the result from simple correlation and VIF, what does it tell? What does it tells you? Do you know how to read the number? If the simple coefficient is actually equal to 0.89, it means that EMP can explain 89% the change in experience, or experience can explain 89% the change in EMP. What does it mean? Means that they are what does it mean? They are closely related. So this one variable, whatever variable, this one variable can explain so much of the EMP. So of course, this is telling you that you have a severe multi-core issue. So how about the VIF? VIF, remember as I mentioned to you, for the VIF, there are three number. Sometimes they said that when you have VIF 4 and above, it is you're gonna have a serious multicore, 8 and above or 10 and above. So here, as if like they just mentioned, just barely over 5 means that it is not even 8. Okay, because they take the number of 8 as a severe multicore. But you have to know VIF is actually testing. What does it test? Testing the relationships of all these variables, whether they have an impact on a particular independent variables. Okay, so they are looking at the group impacts on the a particular variable. But if you want to see whether, because we are talking about the econometric problem that we mentioned just now is actually EMP and experience. So if you just want to see these two relationship, you have to use a simple coefficient, and the simple coefficient is actually very large, means that one variable can explain almost 90% the change of another variable. Okay, even though the VIF is low, it doesn't tell the relationship of these two variables. It tells the relationship of other variable as well. Okay, so VIF is not appropriate test to tell us that these two variables are having multicore. So if you want to see whether these two variables are having multicore, you have to use the test for simple correlation coefficient. Okay, because sometimes students, when they look at, oh, the VIF is small, so there is no multicore. VIF is testing for many or the whole group impacts on a particular variable. Okay, because if you look at here, the unit and the lang, the length just now, they have no relationship. That's why when you want to test the VIF, their relationship for all, of course, they will be very low because these two shouldn't even be in the equation. They don't have any relationship, so it will drag down the value for VIF. Of course, here VIF is not suitable to test for the multicore. Okay, because of having these two irrelevant variable. Okay. So I have explained this thing. Does it change your answer in part C? No. How? Well, because this test says so. Okay. What remedy for the problem? Okay. What is the remedy for your multico just now? What will you recommend? Do nothing? We are talking
Drop,
about multico, right? Should we do nothing?
no, drop one of the variable.
So what variable should we drop? You shouldn't
EMP.
mention. Okay. Some of you just mentioned drop one variable. That's it? No. You have to tell which variable should we drop and why. That's why the question said explain. Why should you drop EMP? Because in the theory, normally we're going to use experience. Experience is one of the relevant variables that can affect the change in your salary, not the years of working. Okay? You have to mention, relate with the theory. If you drop EMP from the equation, so you're going to have this estimated equation. Which do you like better? Means that this is your new one, a new equation without the EMP, and then the previous one with the EMP. Okay, so let's see. You have to look at the R bar square previously. What is the, okay, I think I have to use a different one. Okay, okay. So previously the R bar square is equal to 0.866. What else?
T-score.
What?
We need to look at the T-score. Right, madam?
Okay, so basically your T-score here, you have EMP here. EMP here is actually, basically this is high variance. That's why you have insignificant result, right? Okay. But, well, when you want to say which one do you like better, should you use with the one has EMP or the one has no EMP? Remember, you cannot you cannot decide unless you are using for specification criteria. Okay, so what does it says? This down. One is the theory. What does the theory say about the EMP? Years of working. What do you think? When you are working longer, do you think that your income will be higher? Your salary will be higher? Longer in years. Okay, when you are working, will it be higher? Anyone? Well, of course, right? Yes. Okay. It's because when you are working in a few years, more years, we assume that the theory said that your income, your salary will be higher because longer years of working is associated, of course, with your seniority, with more experience. Okay. Theory said that yes, you should maintain this variable. Uh, okay, provided that the experience shouldn't be there. Provided that. Okay, so theory said yes, maintain. Second, what is the second specification criteria?
R bar
T,
squared. T score.
is it T score or R bar squared?
R bar squared.
Okay,
Right.
okay. Let's just follow your answer. So R bar square, R bar square. So how about the R bar square? This is the previous R bar square. What happened to the new one?
Improve.
Improve. So the previous one is lower, right?
Yes.
So basically, because it is improved, so it suggests that you should drop the EMP, right? Okay, number 3. What is number 3?
T score.
T score. Previously EMP is actually insignificant, right?
Mm.
So what does it say? Since
Drop.
it is not significant, you should better drop. Number 4.
Bias.
Does it cause bias? Okay, if you want to see bias, you have to refer to the previous coefficient because I don't remember. What is the previous coefficient? Okay, so the EMP just now, EMP, the coefficient, you don't really have to worry about the EMP because EMP has been dropped. The other coefficient, unit, the coefficient is 0.002. And then you have, this is length, coefficient is 0.079. And then you have experience. Should I put here? Experience, the coefficient is 0.020. Now let's look at the new one. Does it introduce bias? Unit
The same.
doesn't change. Unit remain the same. Length 0.79 and 81, very little. Experience
Also very small.
very small because you're talking about 0.0. Okay, so does it introduce bias? No. So what does it say? You should also drop. Okay, so this is 3/4. What will you suggest?
Drop the EMP.
Drop. Okay, so it's drop. It's clearly to drop. Okay, now we have finished question F. Okay, what is this? This is 242. Yeah, I think question 6, right? 243. Have we covered 243? Oh, no, not yet. 243 question. I will just go and explain unless you ask me question. Question 6. 6. Okay. Okay, so basically by now you have to remember the 4 criteria, specification criteria. Okay, consider the following regression result. Paraphrase from a study. Okay, what is it about? By the admissions office at the Stanford Business School. So normally standard error in parentheses. So what is this? G is the I don't know what it is. You should know, right? So the R bar square is 0.2. Is it a good estimation? Anyone?
for sorry, for the A is a good estimation. For the cross section, quite good.
Yeah, I mean, this is normal. This is 0.2 is normal. It's fine. The n is 1000. So this is fine. Okay, how about the standard error? Happy with it? See, standard error is very small. Not so bad, right? So as if like you are doing a good job here. Okay, I mean, let's scroll down. What is this G? Stanford Business School GPA. So basically 4 is the maximum. Okay, so this is like your CGPA. So you want to find factors affecting student CGPA. Well, as a student, you should know what factors affecting your performance, right? Okay. Um. Well. Okay. Basically, your result for dependent varies. Okay, so this is CG. I will just put CGPA instead of GPA, right? So normally for CGPA, your result vary from 0 to 4. Okay, so you have a maximum value. You cannot go more than 4. Okay, what happened? Can you guys hear my voice?
Yes, madam.
Suddenly, my textbook closed by itself. I think he said that I'm talking too much. That's why he closed it by itself. So what is the page number? I forgot already.
243.
243. 243. Question number 6, right? Okay. Make it bigger. Slightly. Okay. Okay. So if you have a maximum number, basically you will not use OLS. This is not really a good example, but maybe I think they run out of example. Okay, if you have a maximum number of 4, or you have a cap that you cannot go higher than that, this is what we call truncated regression, and it is not OLS. So it has a different assumption. It has a different way of looking at the problem. But maybe they assume that you don't know what is this, so it's fine. Let's go with the flow. Assume that there is nothing to do with the truncated or whatever. Okay. Okay. So this is their CGPA is a functions of the score on graduate management admission test of the I students. So what is this? Admission test. When you joined IUM, did you take any admission test? Or you have exempted from Arabic, English, and everything?
Oh, still have to take.
Okay, but if you are coming from CFS, basically, if you are not, so you have to take some tests, right? Quranic tests. Are you exempted from Quranic as well? Don't you have to take that?
Yes.
You do, right? You do. Don't tell me you have exempted everything. I don't think so. Okay, so every university, whenever students want to admitted into their university, they will have some tests. Okay, whatever test in our university, we have Quranic test, English test. What else? What else? I think only 2, right?
English.
Quranic and English, right? Oh, Arabic as well, perhaps?
Yes.
Yes.
The-
Well, I don't know because I forgot. I forgot. Okay. Okay. So this is the test. Okay. In fact, their test. Okay, admission test, and the number of years of business experience of the students. Before I go to this, okay, let's look at the first variables. What do you think is the expected sign? What is the expected sign? The admission test. For example, you're talking about English test. If let's say your English test is high, what does it mean? Does it has an impact on your CGPA?
yes.
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 Why?
Mm,
Why? Why? You cannot just say yes or no. This is a third year level, third year course. Why? Why it is it has an impact? I mean, do you expect positive? Means that when your admission test is high, so your CGPA will also be positively affected. Is that what you hypothesize? The answer is not just yes. Why? Why? Because normally there is a reason why they put it as your admission test. For example, for our English, the medium of communication is in English. If let's say you couldn't pass the English test, so you will be having trouble to understand all the courses, all the subjects, right? But if you have passed the test, basically it will help you to understand the subject better. Don't you think so? Don't you think so?
Yes, madam.
Yes, I'm so worried if you didn't say anything because I thought that the internet was cut off or whatever. Okay, so you assume that the admission test will have a positive sign or impact. So how about the next one? Um, the number of years of business experience of the students, of the I students. We are talking about Stanford Business School. Do you think that the number of years of business experience, having experience in business, will affect their CGPA? Do you think that it has an effect? What happened to you guys? You wanna end the discussion? I can see the decreasing marginal productivity. Okay, how about the business experience? Does it has an impact on the students? CGPA? Anyone?
Yes, madam.
Yes. Why?
Or no, because we actually go to school to study business, so I don't think number of years of business experience can impact the CGPA because we are at school to study the business.
Mm. So if let's say they are working people, they have an experience in doing their
Then yes,
business.
yes.
So yes. Hmm. Okay. I can. Well. My answer will be yes or no. Okay. So if let's say some of the students they are not like a fresh students, right? They are doing their job first. They are doing their business. They maybe have a small scale business. They are selling whatever nasi lemak or what curry puffs or whatever, right? So they have spent some times in doing their business. Okay, so because of that, they may have some knowledge on business, and when they want to take a business subject, then it will help to improve their CGPA. But this is the answer for yes, because they have some experience. But I may also think having experience in doing business in the market doesn't really affect your result in business department, the business subject. Okay, because sometimes when you are studying the business subject, they may require you to understand. We are talking about Stanford. They may require you to understand uh, maths, heavy maths, understand the formulas, know how to do the calculation. It may not even related to your previous experience. Okay, so you can say yes or no, but you have to justify. Okay, so let's assume that their experience can help to improve your CGPA because you're doing on business. Okay, and next, age of the students. What do you think about the age? Does it has an impact on their CGPA? If the student is young, the CGPA will be low. If the student is older, their CGPA will be better.
No.
Not really, right? Hmm. So what is the relationship here? What is the sign you want to put for the age?
Negative.
Zero.
Negative mean it has negative relationship.
Zero.
Zero.
If you
Zero.
don't, yeah, so it will be zero relationship. Sometimes they just put the variables because they just wanna introduce irrelevant variables so that you can pick what is the econometric problem. So don't get shocked like why this is age. How should I explain age? If let's say there is no relationship, just make it no, because this is the problem that they want to introduce to you. So age, and the last one is dummy equals to 1. If the students was an economic major and 0 otherwise, what do you think? Economic major. What is the sign? If you are an economic major, do you think that your CGPA on your business, your business school, doesn't matter?
Yes, madam.
Not really.
Why?
Because economics and business are related.
Okay, so business school, basically they are like our economic kuliah of economics. So under business school, they also have economics, they also have business, they also have accounting, they also have finance. So do you think that if let's say because business school is like kuliah of economics, it is just like a school, just like a kuliah. So do you think that, okay, for example, they have 4 department, 4 major, economics, business, accounting, and finance. Do you think that if let's say they are major in economics, their CGPA will be better compared if let's say they
No,
are not?
Mm.
No, right? Not really.
No,
Not
no.
necessary. Not
Yes.
necessary. So what is the sign here?
0.
0.
0. Not necessary. If let's say they are major in accounting, they could perform better, perhaps, right? Doesn't matter you are economic major, so your CGPA should be better. Not really. Not really. Okay, now you have examined the details. So expected sign. Okay, this is normally the first question we'll ask about the hypothesis testing. Even though I skip this question, I'm assuming that you should know how to do it because hypothesis testing should appear in your question, regardless of whatever. This is like a basic question. Okay. B. Do any problem appear to exist in this equation? Problems means econometric problem. Tell me, what are the problems? Anyone? Explain your answer. You have what?
Irrelevant variables.
You have two irrelevant variables and you have to explain. What else? Remember, you always have to say they must be in any equation. They must have omitted relevant. There is no way the equation can give all the relevant. So you have to figure out what is the omitted relevant variable. What do you think can affect your CGPA? There are plenty. There are billions of factors, right? As a student, don't you think so?
Yes.
Yes.
Example.
Time of study.
Hours of study,
Um,
right?
and involvement
Okay.
in curriculum.
Yes, hours of study, two, involvement in, uh, is it curriculum
Yeah, curriculum.
or whatever activity? Three, what else? There are many factors, right? Don't you think that if you have a girlfriend, boyfriend, it will affect your CGPA?
No.
Oh, wow, that's good. What else? They will consume lots of your time, don't you think so? Well, maybe in a positive way, means that you are helping each other, right? But still have an impact, don't you think so? Or there is no relationship at all, 0.
Yes, yes.
Okay, what else? What else? There are so many, right? Don't you think? How about the price of, I don't know, the food in the food in cafe? If let's say you have plenty of food, does it affect your CGPA?
Not so.
Okay, what else? What else? You should know better than me. What affect your
Hours of
CGPA?
sleep, madam.
Yes, hours of sleep. You assume that if you sleep enough, you will be more productive. You can study better. You can focus better. Yes, what else?
Screen
Plan.
time. Madam.
Huh?
Time spent on social media.
Yes. Okay. It will. distract you, right? So you will have lesser time for study. So you can actually list down whatever relevant factors because it's all about you. It's not about me. So I don't know what affect your CGPA. Okay. So so problem is that you have irrelevant to irrelevant variables. You have omitted relevant variable. You can list whatever. And then do you have multi-core as well? Do you have a multi-core here? Admin test and business experience, are they explaining each other?
No.
No. So no multi-core. I cannot explain the serial core and hetero because we are not looking at them yet. Okay. How about the functional form? Remember when we talk about econometric problem, you also have to look at the functional form because it is under specification issues. How about the functional form? This is Lin Lin. Is this a good functional form? You have a dummy somewhere here, right? So your independents are Lin. How about your dependent? How would you measure your CGPA? Is it in terms of percentage or a number, a unit, right?
Yes.
So it's a Lin. Okay. Then Lin is fine. You don't have an issue. Okay. So next, see how would you react if someone suggested a polynomial functional form for A. What is this A? A is age. Why? What would you say if someone said that? Well, age is actually a polynomial. Means that you're talking about CGPA, right? I want to use different color. Okay, so this is age, this is CGPA. So polynomial means that when this is 0. So when your age is increasing, your CGPA increase. After a certain point, you are getting older, too old to study, then your CGPA will fall. How would you react? Should we actually consider this? Will you agree with this? Why or why not? Do you think that when you are older, the more matured you are, the higher your CGPA will be? But after a certain point, you are too old, 60 years old, you cannot study anymore, you have a diminishing marginal productivity, then your CGPA will fall. Do you think so? Anyone?
Yes, madam.
Yes is to respond to anyone or to respond for the polynomial.
The polynomial, the H and the CGPA.
So basically, previously you are saying that H is 0. So do you agree? Let's look at the
Oh.
first. So let's look at the first relationship. Are you saying that the older you get, the higher your CGPA? Means that if let's say in your class you are 20 years old, your friend is 25 years old. So because he's older, so his CGPA will be higher than you.
Oh, not
No,
really.
not
No.
really.
No, right? So remember, you are already hypothesized 0 relationship. Now you are agree with this polynomial. Polynomial means that you believe that they have some relationship, but in the first place, you already know that they don't have relationship. So don't get distracted. Now you get confused with the question. Okay. So now how would you react to the polynomial function? In the first place, you are saying that there is no relationship, so there is no way to have this functional form. Okay. What suggestion, if any, would you have for another run of this equation? Do you know what does it mean? Means that if let's say you're not happy with this equation, uh, what suggestion will you tell? Means that normally what they are expecting to see from you is that you just have to adjust. Means that if let's say you are not happy with the functional form, so change the functional form. But at the moment you are happy with the lin. Okay. If you are not happy with the variables, so drop the irrelevant variable and then add the relevant one. Then write a new equation. That's it. Okay? So is it clear?
Clear.
Okay, I think we have covered everything, isn't it?
Yes.
Yeah, so let me stop the recording first. Um,